In 1995, JavaScript was created by Brendan Eich. In 1997, ECMA produced the first standards document under the name ECMA Script. This wasn't much like the JavaScript that we know of today. It did have prototypical inheritance, and that's probably about the main cool thing about it at that point. Unfortunately, we were already stuck with a lot of the bad stuff that we know of today, such as with automatic semicolon insertion and double equals. Oh well. In 1998, ECMAScript 2 was released, just a minor revision. And ECMAScript 3 was released in 1999. This one was a big release. This came with the triple equals operator, exceptions, the error object, and a whole lot of stuff. Most notably, function expressions, so you have closures. So JavaScript didn't have closures for 4 years. It's crazy. In 2000, ECMAScript 4 started, the effort for it started. Unfortunately, it was just too big in too little time, and it failed. It promised a lot of cool stuff, though, like type annotations, variable destructuring, classes, and a lot of cool stuff. According to the ECMA archives, ECMAScript 4 just never happened. ECMAScript 5 was released in 2008. It came with a lot of cool features, such as a prettier spec page. So we have colors now. We're not in the 90s anymore. It did have a bunch of cool stuff like use strict and a lot of things like getters and setters and JSON parsing. But it was really just an incremental improvement. It was to set the stage for bigger things to come. And that's where we are right now. We almost have the finalized version of ECMAScript 6. And this brings back a lot of what we lost in ES4, things like generators and classes and variable destructuring, a lot of really cool stuff. The problem is that web developers can't use these features yet because we have to wait for all of the browsers to implement them several versions back. It has to have the majority of the market share for a normal web developer to use these. Maybe you're lucky in that you can only target the latest version of Chrome and Firefox, but most web developers have to wait a long time for these things to be implemented. So a quick poll, how many of you all use variable destructuring in your JavaScript today? Yeah, like 2% of people. So 14 years later, after we wanted this, we still don't have it. I mean, I understand why. I don't blame anybody. It's a hard process, especially JavaScript, because there's so many really advanced implementations and engines. But this is a simple feature that could make your code base look so much cleaner. It's crazy. So what can we do? Well, we can write ES6 code and compile it to ES5. Projects like Tracer enable this. And this is really cool. This is a great idea. Tracer implements a host of ES6 features. I think pretty much most of them. I think there are a few things that depend on the additions to the virtual machine that we just can't compile to. But Tracer does most everything else. And this is awesome. This has really helped with early adoption of ES6 features. And that's great. But it's an all-or-nothing proposition. There's something technically wrong with it, but I think a better culture comes when you enable smaller, more independent modules. So if Tracer is missing a feature, like variable destructuring, which it's not, but if it's missing a feature, you just have to wait for that feature to be implemented. It's hard for the community to participate and fill in the gaps. We all know that smaller, independent modules are a better way of doing things. We're JavaScript folks. We live and die by our modules. So the question is it possible to have language features as smaller, more independent modules? So as with anything in computer science, this was solved in the 60s and the 70s. This is a hard problem, so it's probably not completely solved, but I think that it was pioneered way back when. I'm James Long, and I work on Firefox developer tools for Mozilla, and I'm going to show you how this could work. So to show you how we can do this, we need to take a quick look at Lisp. Lisp has deep roots in simplicity. It started out as a small but a powerful language with a simple syntax. In 1963, Timothy Hart proposed a way to keep the language small, but let users add their own forms and extend the language. You could do this with a new special form called macro. Macro, later called def macro, allowed the community to evolve Lisp. Just like adding new APIs, they could add new semantics. The common Lisp object system, CLOS, which was the object system specified with Common Lisp was inspired by two other systems that had already been widely used, common loops and flavors. These were systems way back in the, I think the 70s, maybe the 60s, that had been implemented as libraries. So users could just download these things, add them to their project, and use it. And they added new special forms to define objects, to define methods on these objects. These libraries had already fleshed out these ideas for these object systems. And it was highly influential in the design of CLOS, which was later the object system, which was included in the specification, which is pretty cool that you can use them in the real world before they're actually specified. So here's how you define a method with flavors. You'll probably recognize a little bit more in JavaScript. So obviously, this is not valid JavaScript. Method is a special form. It's somewhat similar to function, but it's a little bit more specialized. It takes the type that you're adding the method to, it takes the name of the method, and the arguments in the code. So currently, there's no way to add this special form method. You'd have to write your own compiler to do it. But if you do that, you can't use any other language extensions that anybody else writes. And don't focus too much on the actual feature. Don't cringe at the actual method. This is probably a terrible way to do methods, but it's just an example of a new special form. So sweet.js is a new powerful macro system for JavaScript from Mozilla. Now, these aren't your run-of-the-mill C macros. Sweet.js provides a powerful pattern matching language for matching on code and sophisticated mechanisms for expanding into new code. It would be trivial to implement that method, new special form, and really easy for users to use it. You just add it to your project, and it's available. The great thing is they can add any number of modules that have macros and use those macros alongside of the method macro. You're not binding yourself down to one compiler. So if you formalize a way to add new semantics, just like you add new features, it makes it really easy to extend the language and really easy to make the community participate in the language evolution. So I have a new language that I want to announce called Emoji Script. This is an example for you guys. Emoji Script features emotion as a value. So currently in JavaScript, you can't actually use emoji, which is a real shame. You have to quote it, but then you're dealing with strings. And it's really just a second-class citizen. But Emoji Script lets you embed emoji into JavaScript. So you can actually assign it to a variable, and you can use it. So emotion literals are cool. So now with a swift Google search for emoji, finding what you want, and then copying and pasting that single emoji into your code, you can do things like emotional algebra. So just a happy person plus fire equals a person screaming in fear. And a happy person plus a punch in the face equals a crying person. A happy person plus a drop of water equals a happy person with a drop of water. I'm not really sure what that one is. You can compare emotions, so happiness is better than sadness. Emoji Script enforces good practices. It actually disallows the use of the double equals operator. Now, maybe you just really needed to use it. Maybe you just love it too much. And you can use it in Emoji Script. So if you want to use it, you have to use the poop operator. This has the exact same semantics as double equals, except it's poop. So there's also a better way a more terse way to throw errors. Instead of having to type out throw new error, you can just use the angry face, and that throws the error with that message. There's also features automatic cat insertion. So why would you terminate your statements with semicolons when you could terminate your statements with cats? So now you get this better expressive language where you can do things like if the user is not happy, then you can yell at them to be happy. There's not really a way to make them happy with software. So if you want to use Emoji Script, you just npm install it. This actually works. You could do this right now. And you use the script emo to compile your file. So Emoji Script is actually just a set of macros. Each of those individual features were implemented as just separate JS files. So you can see there's the algebra, there's the poop macro. I never thought I'd be talking about poop when my first JSConf talk. But so as a disclosure, I did have to patch sweet.js to support emoji, which is unfortunate, but that's just for an example. So you can pick out individual features that you want to use. This command uses the standard sweet.js compiler, which is SJS. And it uses the -m argument, which means you can pass a module to sweet.js to load macros from, and it will use those macros to expand your file. So this just uses the poop feature. Now, I know the irony of me telling you not to use compilers and then telling you to go download the sweet.js compiler. Technically, yes, it's a compiler, but it's really an expander. A macro system adds a new phase to the parse, compile, and execute pipeline of a program, the expand phase, and it happens before anything else. It's really just formalizing this the way that we want to extend the language. And now that since we formalized it, we just have one compiler, and everything else just works together really well, and you get a lot of good things like automatic source maps. So all of the macros automatically generate source maps for free. Sweet.js compiler takes care of that. If you're writing a macro, you don't have to worry about it at all. If you're using macros, you know that you're going to get accurate source maps, which I think that's a pretty awesome thing. So here's a more realistic example. I have a project called ES6 macros. It implements individual ES6 features as macros. You can pick up the whole bundle, or you can just choose one or two features that you want from it. Of course, you can use any other macros. There's some really cool stuff that some people are doing, like pattern matching and things like this. So this is an example of the fat arrow module. If you use the fat arrow module, you can use ES6 fat arrows, and which are really cool because they keep the outer this context. So what my macro does is it just expands it into a function expression, but it calls .bind with this on it. So you get that with just a pretty small macro. There's also a destructuring module where if you include this, you can use variable destructuring, which I still don't understand why people don't use this more, or at least use tracer to compile this, because it makes your code so much cleaner. This is the class module, so you can actually use ES6 classes. My module supports the constructor and as well as super as well, which is not in the example. But if you call super within move, it'll actually walk up the prototype chain and call the move that's your parent. So this expands out to this, which is kind of the familiar class syntax, class function that you're used to. So here's an example of interoperable features. If you just wanted the poop operator and the fat arrow operator, you could just npm install both of those projects, but just pass the poop and the fat arrow module to SJS, and it'll expand your file just with those operators. It interoperates just fine. So writing macros is far easier than writing compilers. Have fun, experiment, and play with things that JavaScript might want to do in the future, things that we don't even know about. This is more than just a better way to adopt ES6 features. ES7 is coming as well, and JavaScript will always be evolving. We should make it easy to experiment and to try new features. And they're all small, independent modules that are easy to write and to use together. So currently, this is the abstract process of adding a feature to JavaScript. There's proposal to TC39, there's discussion, there's finalization, there's implementation, and there's maturation. The maturation phase is basically it's existed out there long enough to where it's taken over enough browser market share. So it's existed in browsers several versions back, because most web devs, as you know, have to support 96% of the browser market share. So this takes forever. Even if we can speed up the discussion and finalization pieces, this creates a gap between the ECMA committee named TC39 and the community actually building stuff, because this takes years, maybe even decades. Now, I think we got stuck on ES6 because this is so large, and I know TC39 is working on ways to push through features faster, more frequent, smaller specs, but the implementation and the maturation phases are always going to take a long time. So I think one way to help with this is to let TC39 give the community features early on, as well as make it easy for the community to create features. Imagine if every TC39 proposal came with a working macro. Anyone of you excited about this in the community could go and just use that right now and test it and flesh it out and see how it actually feels in real-world code. Yes, you can do this with compilers. But what I'm saying is it's really only scalable. It's only really a good solution if you could do it as independent modules. Every feature posted to the mailing list has an attachment that's a macro to make it work. And even better, if everyone in the community who is excited about an idea could actually try it out. They could actually write a macro to extend the language and see how it works. And so the community has a greater participation. So I think it helps close the gap between the community and committees like TC39. Of course, not everything has to be standardized. In fact, I think it's better if we keep JavaScript from getting bloated by standardizing all the things. There are huge advantages to simply using libraries instead of depending on platform features. It works because it works the same everywhere instantly. I mean, there might be a possibility that you're depending on a runtime API that's only available in a specific version, but when you release a library, anyone, you don't have to worry if they're working in Firefox or Chrome or anything like that. It's just a library that you just download and use. The main advantage, too, I think, is that you don't have to worry about backwards compatibility. So any feature that goes into a browser requires a lot of thought because they're thinking, this doesn't break any existing feature, right? This doesn't break any existing syntax. In addition to that, this isn't going to tie us down into one thing in the far future because the browser is always completely backwards compatible, which I think is awesome, but it kind of constrains the language in some ways. If a breaking change, if you released a feature as a macro and you needed a breaking change, you could just either fork the library or do like a major version bump and maintain 2 different libraries. Because it's a library, it's not hooked down to the JS engine. So they give a formalized way to treat new language features as libraries and allow the community to experiment and use things that will probably never be in the JavaScript standard. Or will Emoji Script ever be in the standard? It might be. But in all seriousness, changing language semantics should not be taken lightly. Don't use macros just for inlining code. Don't use macros just to remove curly braces. Honestly, if you're thinking of writing a macro right now, you probably shouldn't. I mean, how can I say this after everything I just said? I think it's because we need to be grounded. Don't experiment on your company's code base. Don't cut off the community by using weird features. Only write a macro if the feature is unique enough and you have time to invest in teaching people why it's useful. Common Lisp, in my opinion, kind of fell prey to this. It's just way too common to write macros. If you're working on your web app, you probably will write some macros to do something. This just creates too much confusion, too much divisiveness, because the semantics are changing just too much. In my opinion, Clojure did it right. They have just enough built-in functionality so that you don't always have to be writing macros. And the culture actually discourages macros, in fact, which I think is what we need to do as well. But we can't simply discount macros completely. Don't be afraid. Clojure was able to release a library called CoreAsync, which is somewhat similar to generators. They're different in many ways, but the core functionality is that they can pause and suspend execution of a function. They were able to do this as a library because they implemented a Go block, which is a new special form, and it compiles the code inside the Go block into a state machine that they can control. It's all just a library. When they release it, everyone can download it and just immediately begin using it. They don't have to wait for a whole standardization process. And 10 years from now, might be able to use it. So I think this is especially important for JavaScript. The language evolution is already happening. I mean, look in Angular. They're talking about this extension to ES6 to make ES6 Plus, where they have this dependency injection weird stuff. And I think this is fine. I think it's good to think of ways that we can improve our code. But I think they're planning on forking Tracer. I could be wrong with that. Or they're planning on forking a compiler and adding some extensions. The more and more you do that, the more and more you're siloing yourself away from the JavaScript community. I think JavaScript needs release valves because it's just such a massive language. It's used everywhere. So macros can be useful even if you don't change semantics. The Emoji Script poop feature disables double equals. And this is how that works. I'm not going to go into the details, but I'm able to throw a syntax error within my macro. So whenever the double equals operator is invoked, my macro is invoked, and my macro throws a syntax error. So at expand time, it just throws a syntax error and says that's not allowed. So this is an interesting way to not only expand the language, but kind of restrict it as well. In fact, if you wanted to use macros, but you didn't want anybody on the team, especially that overeager college grad that you just hired, to create macros and go crazy and change things out from under you, you could just disable macros entirely across your project. Just create a macro called macro and throw the syntax error and say you're not allowed. So here's another example of macros that don't introduce new semantics. Macros allow certain forms of aspect-oriented programming, which means you can change behavior or add behavior to certain parts of your code without actually changing it. I kind of just made that up. I don't really know what aspect-oriented programming is technically, but look at the wiki page. I made a macro that traces all function calls. It overwrites the function keyword and injects a console.log at the beginning, calls the function immediately and gets the return value, and then adds another console.log of the return when the return is happening. And I'm able to pick off the name of the function. This is actually just one part of the macro. The real macro that I wrote is a little bit more sophisticated, and it's able to pick off the name of the function, even if it's like an object property, you know. So I took this macro and I ran it through, and I ran jQuery with it. So it expanded jQuery with this. And so with this, it's really interesting. I was able to run this jQuery code and say, what does the execution look like within jQuery? So I can grab an element with the ID of app, and I can set the HTML of it to the div with the class box. And I can kind of see the shape of what's going on within jQuery. So if I wanted to learn what jQuery was doing, maybe I wanted to start working on jQuery, I just immediately see this interesting functionality. Now, certain dev tools, I think, are starting to implement things like tracers. But you wrote this for your app, for your code and project, and you know what you're wanting to look for. So you could do all sorts of things with macros that are specific to your app for debugging your app and logging your app and doing all sorts of interesting things that don't actually change semantics, right? They're just adding interesting logging capabilities. So nobody else on the team doesn't even have to worry about what's going on. So here's something a little crazier. This does add new semantics. Can we implement a simplistic stack allocated type system? So we can get something basic working, I think. First, let's allocate one big typed array, our stack, and create various typed views into it. And my stack allocated type system allows you to write code like this. You can define a record type. So you have point with fields, and they all have types. And these types are just kind of the machine low-level types like double and float and uint and int and short. But now you can instantiate one of these records, and it essentially allocates it on our stack, which is that big typed array, and this sets the x and y to 180. This expands all the way down to this. So I grab the current stack pointer, and that's essentially my stack allocated object. It's just a pointer. And I move the stack pointer, and then I set the pieces in my stack to 180. And I'm accessing it through the float 64 array. And you can see the pointer. So the first one is my stack allocated object pointer. And then the second value, y, is that plus 8, because it's 8 bytes wide. So we can have typed allocated structs and compile down to this. This lets you avoid all those pesky allocations if you're writing like heavy graphics code. It's a very interesting way to kind of interleave this. Haven't put a whole lot of time into this. If I knew type theory better, I'd probably do something a little bit different. If you wanted to like return this, you can do that. But you could essentially copy it onto the heap if you wanted to do that. But there's a lot of times when you're writing graphics code and you just want a bunch of local vectors to do some computationally heavy work. And always doing the object literal x and y is just hitting the garbage collector for no reason. So who knows? Maybe one of these features does turn out to be so useful that it does become standardized. Something that we wouldn't have thought to propose at first. And now it will be based on real-world usage, and most of the problems with backwards compatibility will already have been solved. It would be neat if JavaScript even integrated sweet.js itself natively. But if that does happen, that's probably a long ways off. But I think it could be neat to do something like a browser add-on that integrates it automatically. And then for production, you just pre-compile your code. Of course, some levels really do require platform-level integration, just things like weak maps. But I think those are actually relatively rare. So let's look at what sweet.js, if you wanted to actually write macros, some of the features that it gives you to actually do this, because I haven't showed you any of the actual code. So it features pattern matching, various expansion strategies, and hygiene. So these are fully hygienic macros. So if you're familiar with macros, you know that that's pretty much necessary for a real-world macro system. So pattern matching, you've seen this to some extent. This is just a basic pattern matching. You have a list of rules, and the sweet.js system will invoke your macro. So you have a macro named var. Your macro will be invoked when it hits the keyword var in the code, and then it will walk down your rules top to bottom and see if it matches a rule. And if it doesn't match a rule, it'll throw a match error. And when it does, the first rule that matches, it will expand into the code that's within that rule. So this is a basic variable destructuring array. So you can see that the first rule has a curly brace, and then a name, and then multiple repeated names, and then equals object. So you can bind current syntactic elements to pattern variables with the $sign. So that basically says, whatever is here, just bind it to me. And then the dot, dot, dot means match repeated elements. It's just a brief overview. So that's the rule macro. This is a rule macro. You just have a list of patterns. There's a let macro, which is essentially the same as the rule macro, except you define it saying let var equals macro. And what this does is, by default, macros are recursive. So when a code is expanded, it will re-expand it. And that means that you can't, if you want to do something like override the built-in var keyword, you couldn't do that. A let macro does not recursively expand. Well, I'm sorry, it does. But a let macro, the var that we've referenced within the macro doesn't reference my macro. It references what it was defined as before my macro, which was the built-in var. So this will not recursively infinitely loop, which it would do with a normal macro. There's infix macros, which let you specify a pipe or a bar in your pattern. And that means you can look, and that bar indicates where that macro matched. And that means you can match before the syntactical element that you've been invoked on. So for the arrow function syntax, the fat arrows, we need this because we need to look back and grab the arguments. And so this is a basic fat arrow. This is actually most or all of the fat arrow macro. You get this, you get fat arrows with this macro. I think it's actually missing one rule for one style of fat arrows. But this is how tiny it is. You don't have to write compilers. This is a little bit more complex, but there's a special form called operator, which defines a new macro, but it's has a little bit different semantics. So this overrides the plus operator. It takes the precedence and the associativity. So 12 is the precedence level. So if you think of operators, they all have a precedence level, like where they group together. So plus, I'm giving it 12, which I think is what the default is, and then a left associativity. So you can see that it expands into a function called add. So 1 plus 2 plus 3 plus 4 expands into this, and it groups 1 and 2 first. If I change the associativity to right, then it's going to group 3 and 4 first, and then expand out from there. So this is why you need this special form operator, because it has the precedence and the associativity, and things that you can do with the other macros. And this is the last one. This is the most complex one, and one that should rarely be needed, really. It's case macros. These macros actually let you run arbitrary JavaScript within the rule. So it takes a pattern. This is a little bit different. It takes a syntactic element that it bound on as the first argument, or as the first piece in your pattern, and then you have your whole pattern. But then you can execute any JavaScript within this expanded code. So I can check if this condition isn't true, then throw a syntax error. And this lets you do things like break hygiene, which I'm about to talk about. So hygiene, like I said, these are hygienic macros. This is crucially important. It's a basic thing that you need for any macro system that's going to be used as modules. So the problem with macros typically is we've defined this square macro. If square x expands out to these 2 lines of code which have another var x. So if it was just a naive macro system, I would have two variable declarations with the name x, and they would collide. And they would overwrite, and it leads to really strange bugs. And it's just you really need hygiene to actually have a sound macro system. So what sweet.js does is it actually renames the variables. So the first x is renamed $$1, and the second one is renamed $$2. So it renames everything to make sure that it's right. So this is the very last thing I'm going to talk about. You might be sitting there thinking well, this is totally all cool. I would use this except for one thing, and that's that it breaks my syntax highlighter in my editor. So I looked at a lot of syntax highlighters, and they're actually pretty loose. Most of them are regular expression-based. You can do a lot of weird operators and stuff. This is IntelliJ. I just chose it because it's just a really random one that I thought would be a little bit more intrusive about how it's actually parsing the code. But it actually worked fine. It didn't really throw any errors. Most editors are pretty flexible, and they're just looking for the keywords, and they're just looking for basic delimiters so that it can indent the code right. And it just pretty much ignores everything else. There are a few exceptions. JS2 mode in Emacs actually literally parses the JavaScript code in your buffer. So that does break that. But honestly, the more I think about it, the more I think that some of those things aren't worth the return. Because I really don't use, it tells me when I'm missing a semicolon, and that's cool. But JSHint can tell me that, or some other thing can tell me that at some kind of build time that's happening. I'm starting to think that some things like that might actually end up holding back JavaScript, because a lot of people don't use ES6 because not only is ES6 not implemented, you could use it with Tracer or something, but a lot of these other tools haven't implemented, like editors haven't implemented like the fat arrow syntax, so the editor breaks. So I'm actually starting to think that things like editors, the looser the highlighting is, the better. I mean, maybe I'm a little bit biased because I do like to use macros, but I've actually seen like Vim works great with different operators and stuff like that. Basically, anything on a new line that is still part of the previous expression is just indented like 2 or 4 spaces, and it just kind of doesn't care what it is. So just a quick recap, JavaScript is under a lot of pressure to evolve, and sweet.js provides powerful macros for adding these features as libraries, and we can test them out early, we can try them early, and see if they work. Compilers can't work together. They're great for some things, but for specifically language extensions, they're a little bit more, they tend to create silos. And we can help TC39, we can help liberate JavaScript, so we don't have to wait 14 years for variable destructuring. That's it. Thank you.